Hello and welcome to the next chapter, which is equations and inequalities, and we're going to look at the first topic, which is linear simultaneous equations. And linear simultaneous equations are two equations that have x and y in it, even could have a z, but that is not, that's beyond pure maths, and we're going to just work with two unknowns, just like in GCSE. So first of all, we have 2x plus 3y equals to 8 and 3x minus y equals to 23. Now here we have two techniques that we could use. We could use an elimination technique, which is multiplying the whole equation by a certain number to eliminate the y's or the x's, so that we could work only with the y part or with the x part. And another technique which is used is called the substitution. And the substitution works in a way that in one equation you find the value of y to substitute that into the second equation of y to find the value of x, or you find the value of x in the first equation, replace it with the value of x in the second equation to find the value of y. So what happens here is that my equation number 2, so we have equation 1 and 2, my equation number 1 has y on its own, so that's what I'm targeting. Because what I can do is I can make 3x minus 23 equal to y by moving y to the other side and 23 to the other. And what happens now is that I got 3x minus 23 equal to y. Now I can substitute my equation 3 into equation 1. So 3 into 1, so that will be 2x plus 3 and then the y equation, which is the 3x minus 23, equals to 8. And now we can work out for x. So 2x plus 9x minus 69 is equal to 8. Now 11x equals to 69 plus 8, which is 77. And we have x equaling 7. So that is our first unknown that we know. And when we know x equals 7, we can now use the equation 3 to solve for y. So y equals to 3x minus 23. We know that x equals to 7, so 3 times 7 minus 23 is going to be 21 minus 23, which is minus 2. And here we have two unknowns that have been found, x equals 7 and y equals to negative 2. Now we got another set of equations. So what happens here is that we can eliminate y's or x's, it depends which one we prefer, to find the value of y and x. So what happens is I can multiply this equation by 2, and I can multiply this whole equation by 5, because what I get here is if I multiply whole equation by 2, I get 8x minus 10y equals to 8. And if I multiply the bottom equation by 5, I get 30x plus 10y equaling 125. So what happens now is that I can eliminate the 10's, so 10 y's together. So how do I get rid of those two y's? Well, it's simple. We have to do minus 10 plus 10 to get 0y. So we adding the equations together. So 8 plus 38, 8 plus 30 is going to be 38x. Now minus 10y plus 10y is going to be 0y. And 8 plus 125 is going to be 133. Now we have to do 133 divided by 38, which is x equal to 3.5. Now we can use this value of x to find the value of y simply by substituting the value of x to the value of x in the first or second equation. So we are going to use 4x minus 5y equals to 4. We are going to make y the subject, so 4x minus 4 equals to 5y, and y is equal to 4x negative 4 over 5. So now we make x be 3.5, and we work out this value on a calculator, and we get y is equal to 2. So here we have x equals to 3.5 and y equals to 2. And that is the two methods that we are going to use, the method by substitution and the method by elimination. Now I have to solve the simultaneous equations, and I'm going to use both the substitution and elimination. So here we have the elimination and substitution method for the one question. So I'll be showing you how to tackle with first and second technique. So by elimination, we have to multiply the first equation. So we have to multiply the first equation by 2, because if we multiply this first equation by 2, then we get 2y for 2 equations. What happens here is that we actually have two values that are actually similar, so 4x and minus 2y and 2y. I'm going to choose to eliminate the y's. So to eliminate the y's, I need to do minus 2 plus 2. So I have to add the equations together. So 4 plus 4x is 8x, negative 2y plus 2y is going to be 0y, and 2 plus minus 30 is going to be negative 28. Now using division, we can do minus 128, we can do minus 28 over 8, and we get negative 7 over 2, which in other words is going to be minus 3.5. Now I can use my first equation, so 2x minus y is equal to 1, to work out the value of y by simply making y the subject. And now what I can do with this equation is that I can input the value of x, which is negative 3.5, and the value of y is negative 8. Now I'm going to do the same thing with substitution. So substitution, we have to make something the subject to substitute into the other equation. I'm going to use the equation 1, so making y the subject will be 2x negative 1. And here we are going to substitute the value of y into 2. So we're going to substitute 1 into 2. So that means 4x plus 2 of y is going to be equal to negative 30. And now if we tidy all this together, we are going to have negative 28 equal to 8x. So again we have 8x equals to minus 28 and x equals to negative 3.5. Now by using the y equation, we can substitute the value of x into y, and that's how we get y equals negative 8. So here we have slightly different approaches, but they're all working the same. We get the same result, and whichever method you like, you can use an exam. Unless it says that you have to solve by a specific method. Okay, and here we're going to go to the exercise questions. So here we got two simultaneous equations for which k is constant, and we have to show that x is equal to 3. So here we can actually eliminate the k and y by elimination, and what we can do is multiply the first equation by 2, so that 6x plus 2ky is equal to 16, and that makes it so we have 2ky's. So now if we have 2ky's, we can now decide if we have to negate or to add the equations together. So plus 2, negative 2, so we have to add the equations, because plus 2 plus negative 2 is 0ky, and that's what we want. So now 6x plus x is 7x, and 16 plus 5 is 21. Now x is gonna be equal to 3, because 7x equals to 21, both sides get divided by 7, and therefore we have x equals 3. So we have shown that x is equal to 3, which means that now we can substitute the value of x into the value of our simultaneous equations, and we can find other values like k that we have to find in question B. So here we have been given that y is equal to a half, and we have to determine the value of k. So here we got the equation of 3x plus ky equals to 8. Now from question number 4a, we got x equals to 3. And from question B, we got that y is equal to a half. So here we can just substitute both values into our first equation of simultaneous equations, and we get 9 plus a half of k is equal to 8. Now we bring minus 9 here, and we get negative 1 is equal to a half of k, so k is equal to negative 2. Now we got the last question that we're going to do today. So 2x minus py equal to 5, and 4x plus 5y plus q is equal to 0. So they are simultaneous equations where p and q are constants, and the solution to this pair of equations is x equals q and y equals negative 1. And we have to find the value of p and the value of q. So what happens here is that actually the value of x is q, so we can change the value of x to be q, and we can change the value of y to be negative 1 in our pair of simultaneous equations. So what happens here is that 2 replaced q, replaced x, so that's q, minus is actually plus, because minus 1 is going to be plus 1, so that's plus p equal to 5. So what we're essentially doing is substituting x equals q and y equals minus 1 into our first equation, and now into our second equation. So 4q plus, minus 5 plus q is going to be equal to 0. So now we can turn this into 2q plus p equals to 5, and 4q is plus, actually this will be 5q is equal to 5, so q is equal to 1. So now we can find the value of p by substituting the value of q, and now 2 multiplied by 1 plus p is equal to 5, so now p is equal to 3. Really simple, matter of substitution. So now you can do exercises for 3a and hope that you understood what was going on in that exercise.